Welcome again everyone, and today we are going to solve a new question, and this question is to construct a binary tree from in-order and post-order. So this is a continuation of the last question in where we have used our pre-order and in-order in order to construct a binary tree. Now here we have been given in-order and post-order, and we have to construct a binary tree out of it. Now let's see how we can do this. So here I have taken the example one from the question, and now let's understand the question, how we are going to approach this question using the first example. Now you already know that there are three type of DFS. First is our in order, second is our pre-order, and third is our post-order. So these are the three type of traversal which we already know, and you know that in order it means that we have to first go to left, then we take our node, then we go to right. Now let's move to the next one, which is pre-order. So in pre-order, what we do, we first go to node. That means we first take the node, then we go to left, and then we go to right. And in post-order, similarly, we first go to left, then right, then take node. So these are the three type of traversals by which we traverse in a tree. Now in this question, you can see that we have given in order and post-order. That means we have been given this one and this one. In the last question which we have done, what are the two traversals which have been given? So the two traversals are our in order and pre-order. These are the two traversals. Now it is important to understand that why we have been given, why we have to choose from these two. So this is the traversal from which we are choosing one traversal, and this in order we are taking in both the cases in order to construct a binary tree, unique binary tree. So it is clearly you can see that in if we have been given a pre-order or post-order, you can easily find the root because the root either exists on the first of the traversal or at the last of the traversal. So you already know that if it is post-order, that means the root node is at the end, and if it is pre-order, the root node is at the start. So using this, you can traverse and find it in your in order. So what is in order? It means that your root node is in between the left part and right part. That means if you are able to locate the position of the node, then you already know the left part and the right part. And this left and right are acting as their unique binary tree. That means you can construct or find the all nodes which are on the left and all nodes which are on the right, which again behave as similar to the same situation. That means it again behave as a in order for the left part and the right part. So now let's understand in this example what will happen. So we have been given the post order. That means the last node is 3, which is our root node. So this 3 is our root node. Now if you know 3 and you are able to get the position of 3 in order. So here is the position at the second position. So what it means that all the nodes which is before our root node, which is 3, are for the left side, and all the nodes on the right side are of the right side. So this gives us an in order for the left part and the right part. And in the post order, you if you know the size or length of the in order on any one side, left or right, then you can find by counting it. Because you know in post order, here you can see in post order, in the left side we have left part and then we have right part. So if you are able to get the length of the left part, then you can get the length of this left part, and the rest of the nodes before the root node are of the right part. So here what we got the left part and we got the right part. So it is important that using this you can simply get left and right for in order and post order. So what we have in hand, so we have in order for left part and we have post order for left part. Similarly, what we have in order for our right part and we have post order for our right part. So what you can see that we have break the question in subcategories, which is two parts, first for left and second for right. So we have first taken the root node and we have moved on to the left part and to the right part with its respective in order and post order traversals. Now let's understand by coding that how we are going to do this. Now let's start the coding part, and you already have understood that what we are going to do is that we are going to use the recursion in order to construct our left and right part. So for that to begin, what we need, so first we need a root node because we need to construct a binary tree. So we need to combine the nodes. So first we are going to take the root node. So let's initialize a node which is going to be our root node. Okay, so let's give it value. So what is the value it is going to take? So if you are constructing your root node, that means it is going to take the root node value, and what it is the last element in the post order. So first let's take the size, int s equals to your post order dot size. And here you can, what we can do, we can simply provide the value, that means post order s minus 1. So this is the last position in the post order, which is our root node. Now after this, what we need, so we need the index of the root node in our in order. So we are going to take int I equals to 0, and we are going to run a while loop, and this while loop is going to run until our we are not able to find our post order s minus 1, which is our root node. In where we are not able to find, so we have to find it in our in order. So we are going to do in order I. So it is going to traverse in order to find our root node, and we are going to plus plus. So what it is will return, so it will return the position or index of the root node in order. Here you can see your root node is 3, and when you try to find out it in order, what you will get at first position. Here I is also going to be equals to 1, because after one while loop, one loop, you are going to get that. Now let's understand what we're going to do next. So next part is we have to construct the left and right part. Now you already know that in order to construct the left and right part, what we can do simply is that we can provide the in order and post order for both left and right separately. They will automatically, what it will do, it will automatically use recursion in order to construct a binary tree on its own. Now here is one condition which we have to take in consider, that if your 3, which is root node, is at the first position in order, what it's mean? So if it is at the first position, it's mean that there is no left part, because your in order is left, root, right. So in that case, we have to skip the call of recursion for the left part. And when your post or and when you get that your root node is at end in the in order, that means there is no right part. So we have to again skip for the right part recursion. So let's start. So first we have to check the conditions. We are going to check that if your I is greater than 0, then only we are going to call the recursion. And again the next which we have discussed, that if our I is less than your s minus 1. So if this is the case, then we are going to call for both left and right part. So what are the left and right part? It is going to be your root left, and here what we have to call, we have to call root right. What root right? Okay, now let's see how we are going to call this. So firstly, what we have discussed, that we have to construct in order, and we have to find out the in order and post order for both sides. So we have to construct in order for your left, and a vector your post order for left. Now let's assign the values. So what it is going to take, so you already have in order. Now let's see how we are going to slice it. So we are going to start. So here you can see that your what is in order. So your left part is from the beginning until the length of the in order. So you already know that your root node is at the first position. That means all the elements before it are for the left part. So using this concept, what you can do, you can simply start from beginning, and until where we have to check, until where we have to do this. So we have to do this, and until in order dot begin plus I. And what it is plus I? So plus I is your position where you have find your root node. So here you have find your root node at first position. That means there is one node which is going to be for left side. So we have to start from the beginning, and we have taken the elements until that one position. Now let's call or find the post order for your left part. So here similarly we are going to do. So let's copy this and paste it here. Now here you can see that you have post order, so we are going to update it. So in post order, what you have, so in post order you have left, right, and root. So that means from the starting we have to take the values, and until which position we have to take the values. So this position is going to be your length. That means the number of this length is going to give us the number of nodes in the left part. So in the both the vectors, the same logic is going to be applied, and simply what we are going to do is that we are going to call this build tree. And what are the parameters which we have to pass? So we have to pass your in order for the left and your post order for the left. Now let's move on to your right part. Now let's copy the complete code and paste it here. Okay, now here you can see that what is the case in here is that we have to call for right part. So let's take is at update to ir and pr. It is going to be in order for right and post order for right. So how we are going to do in here again? Let's see that here in the in order, your post or your in order is just starting from the position next to the root node which you have found. So we have found it at ith position. So that means there are two things we have to escape in order to start. First is I. What it is? It is your left part, and plus 1. What it is? It is your root node. So we have escaped both two. That means you have escaped 9 and 3 in order to start your vector for your right part. And until when we have to do this? We have to do this until end, because all the values after that are belongs to right side. Now in post order, similarly as you have done, here you can see that in your post order right section is just starting from the from the elements skipping the left part. So what is the left part? It is I. So plus I. There is no root node because root node at the end. So we have to simply write it as end minus 1. So we have simply ignored the last node which is your root node and taken all the values. Now similarly to the previous one. Okay, so here we have that included. So here we have to assign to build tree. So we are calling build tree for again. So here we are calling for our in order right and our pre order right, sorry, post order right. So here at it, what it will do, it will automatically create the binary tree for both left and right side. Now we have to simply return our root. Now let's run this code. Okay, so here we have forgot to place new. Okay, now let's run again. Okay, so we have forgot semicolon. Let's update it. Now let's run this code. So this is accepted. Now let's submit this. So this is accepted. So this is a question for today, and this is the simple question which is a continuation of the last question which we have did, and the same logic we have applied in the previous question also. So you can see that video also. So these are the two types of traversal, or two types by which we can create a unique binary tree. Now let's meet in the next video. Until then, keep learning and exploring, and you are going to see the solution for both Java and Python in the same video. So keep tuned and let's solve a very interesting question again of the binary tree in the next video.